Today we're going to construct a log C versus pH diagram of a closed system monoprotic acid and an open system diprotic acid to illustrate the difference between an open system and a closed system and illustrate a difference between a monoprotic and a diprotic acid. Now, the important thing about an open system is that we will need a different set of numbers to calculate the concentration at a certain pH. So for our diprotic acid, and today we are going to use carbonic acid, we are going to need its partial pressure, its Henry's law constant, the pKa1 and the pKa2. Notice that the Henry's law constant is temperature dependent and we are using it at 25 degrees C. So if you are given a situation at a different temperature, you will have a different Henry's law constant. Our pKa1 represents the pH at which the first deprotonation happens, and our pKa2 represents the pH at which the second deprotonation occurs. Now for our monoprotic acid, which is going to be acetic acid, we're going to need to start out with a initial concentration of -2, and these are in log units, so it's actually 10 to the -2 molar. But we use log units because it will be simpler to graph instead of using the logarithmic scaling, and I'll show you what I mean when we graph. And the pKa of acetic acid is 4.76. So now we need to input our pH range from 0 to 14. And our log of our hydronium concentration is going to be negative of the pH. Notice that pH is already in log units. That's the definition of pH. And then for our log of the hydronium concentration, or hydroxyl, concentration, it's going to be 14 minus the pH and the negative number of that. It'll share an opposite relationship with the hydronium concentration. Now for our carbonic acid concentration, note that since we are in an open system, this concentration will remain constant over the entire pH range, and here's the equation for that. I already have it input, and notice I already have the log of that equation that you can see on the right. So now we'll fill tab that down to the 14, and good, that pH is remaining constant since it's dependent upon the partial pressure and the Henry's law constant, and that doesn't change given pH. Here is our equation for bicarbonate. Notice that it's dependent upon the concentration of carbonic acid and the pKa1 and the pH, so that will be varying over our pH range. And we can see that looks good. Here's our equation for our carbonate. Notice again that will be varying over our pH range. Good. Okay, so now we have all the numbers necessary to calculate or to construct a log C versus pH diagram, but first we're going to have all our concentrations for our acetic acid. Or here's our equation for acetic acid, our monoprotic acid. Notice that this concentration will be changing over the pH since we're in a closed system. And here's our equation for our deprotonated acetic acid. Good. So now we're ready to make our graph. So first we're going to start off by highlighting the pH and log H. Then we're going to charts, XY scatter, and then we're going to click on smooth line scatter. We should get a line like that. That looks good. So now we're going to right click on that line and click select data. We're going to add a name so we can identify what line is what. We're going to highlight the X values because highlight and copy the X values because that will always be the same in every series we add, and our Y values will be different. So now we're going to add. Our new name now will be our OH, and we're going to paste our pH range, and we're going to find our OH. Good. OK. So I'm going to click OK because I want to now move this out of the way so we can find our other concentrations. We'll place that over there. Now we're going to again right click, select data, add series. Our new series now is going to be our H2A, our carbonic acid concentration. Paste those pH range, and now we're going to select our carbonic acid concentrations. Should be a straight line because the concentration is remaining the same. We're going to add a new series, name HA, because that's the first deprotonation. Our X values, we're going to paste those in there, and now for our Y values in BRHA. You guessed it. That looks good. Now we're going to add, and we're going to name our A. That's when our second deprotonation happens and both protons are lost. We're going to paste our pH range, and we're going to add in our concentration. Nice. We're going to click OK. Now we're going to right click in the chart area and move chart so we can see it a little better. I'm going to name it Open System Diprotic Acid. So now we need to format this a little different because we don't need this scaling. So we're going to click on the vertical axis and right click, format axis, scale, and we don't need to go down to -25. We're going to go down to -20. Our max doesn't need to be 10, it just needs to be 0. Now notice, since we did use log units the entire time in our equations, that we don't need to click this log scale, logarithmic scale. You would need to use that if you just simply put in the concentrations. Good. So we're going to click OK, and now we're going to click on the x-axis, right click, format. Now we're only going up to 0 to 14, so we don't need to go to 16. Now that looks good. Notice that the green line is our carbonic acid concentration, and that is a straight line all the way across, which is what we would expect. Alright, so now we're going to go back to our first sheet, and we're going to construct a diagram for our closed system monoprotic acid. We're going to start off the same way. This is still highlighted, so we're going to highlight our pH and log the hydronium concentration, charts, XY scatter, smooth line scatter, right click on that. Actually, let's move this chart out of the way so we can see our concentrations. And we're going to right click on our chart, select data, name this series. Very important to name everything so you keep everything in track. I'm going to go ahead and command copy, add series, our OH now, paste, and our OH concentrations. There we go. And add, and name, and this is going to be our HAC, and I'd use the HAC because it's acetic acid to differentiate from our HA from our carbonic acid, so you guys wouldn't get confused watching this video. Now we're going to paste our pH range, and we're going to highlight our acetic acid concentration, and there's that guy. We're going to add name. Now simply AC, because it's been deprotonated, we lose that H. We're going to paste And now we will add in this guy, our deprotonated acetic acid concentration. Click OK, and we have everything in there. We're now going to right click in our chart area, move chart, new sheet, closed system monoprotic acid. So now again we're going to need to reformat these. We're going to go click on our Y and format axis. We don't need to go down to -16. We can go down to -10. Our maximum 0, that looks good. And again, we would use logarithmic scale if our units were already not in log units. So we're going to click on that. Now we need to rescale this x-axis. Click, right click, format, scale 0 to 14. So notice that here's our legend with everything clearly illustrated on what everything is. And notice that at our pKa of 4.76, which occurs right here, this is when the deprotonated form concentration starts to dominate. And as you can see, this is our pH, so that looks to be about 4.76, what we'd expect. And that is how you make a log C versus pH diagram of a monoprotic acid right here and a diprotic acid right here. Hope that helps.